Morning everybody, welcome to our first AP Chemistry online tutorial. So today what we're going to do is address some review properties and then one other new material. First of all, it says today's objective is going to be the Bronsted-Lowery definition of an acid and a base, and then how to identify conjugate acid base pairs, and then finally make sure that we know what just the definition of dissociation means. So before I start, let me just go and talk about dissociation. Dissociation just means it's dissolving in water, and that's what we're looking at. How do acids and bases dissolve in water? So let's go through and look at the definition of Bronsted-Lowery. Bronsted-Lowery definition of an acid and base is a little bit more detailed than what we've done in the past. We've always said if it has hydrogen ions, it's an acid. If it has OH ions, it's a base. But now we want to look at a couple of exceptions. So Bronsted-Lowery incorporates a little bit more. First of all, Bronsted-Lowery says that an acid is going to be the substance that donates a hydrogen ion, whereas a base is going to be the substance that accepts the hydrogen ion. Has nothing to do with OHs, it just has to do with the transfer and acceptance of a hydrogen ion. So let's go through and look at what is known as a conjugate acid base pair. So when I look up here, I have, in this example, I have hydrochloric acid, HCl, plus water. We know when hydrochloric acid is placed in water, it's going to dissolve. So when it dissolves, we say it dissociates. Well, this is a no-brainer. HCl, hydrochloric acid, that's an acid. So if it's a traditional acid, you don't have to look to see which is the acid, which is the base. Hydrochloric acid has to be the acid. So in this one, I know that HCl is the acid. So if HCl is the acid, by Bronsted-Lowery definition, it has to donate a hydrogen ion. If it donates a hydrogen ion and it only has one hydrogen, then we say it undergoes first ionization whenever it goes and donates just the hydrogen ion. So what's going to happen is the water, H2O, is going to accept the hydrogen ion. So water becomes H3O with a positive charge. Now, in chemistry, you don't really have a hydrogen ion floating around. Those hydrogen ions are attached to water molecules as hydroniums. So this is called a hydronium, which is what we've always referred to as nothing more than hydrogen ions. So now, I look back over here. If I donate that one hydrogen, what do I have left? Just a chlorine. But it's not chlorine as a gas or a solid, it's a chlorine as an ion. So I get this. And this is how hydrochloric acid is going to dissociate. So let's look at the next one. This one is carbonic acid. It's got H2 plus water. So what's going to happen is, since it has two hydrogen ions, it's going to have to go through first ionization, then second ionization. So the first ionization is it donates. So I have the water accepting H3O positive. It can only donate one hydrogen at a time. So now I get HCO3 with a -1. And this is going to be the first ionization, or the first dissociation. So now I'm left with this over here, which has still got a hydrogen ion. So I can go back in and set it up and say HCO3 minus plus a water, and I can undergo the second dissociation. So now I'm going to get, again, H3O, hydronium ions, plus, this time I get CO3, but now it's going to be -2. But the key factor here is it must go through 100% of all of these before it goes into these down here. So it's going to go 1, 2. So that's pretty much it. Conjugate acids and bases. What I want to do now is just simply go through and say, how do you go through and identify what's the acid and what's its conjugate base, or what's the base and what's its conjugate acid? Well, if I look over here and I say, okay, these are my acids, I'm giving them. It says, hey, this is an acid. Well, an acid has to donate. So that means that if it donates, I'm going to be left with one hydrogen, SO4, at a -1. So that's what it's left over with, so that becomes its conjugate base. Down here, this is acetic acid, HC2H3O2. If it donates one hydrogen, I'm left with an acetate ion, C2H3O2 -1. That's its conjugate base. Well, on this other side over here, I tell you that these are the bases. So bases have to accept. So that means that I'm going to be looking for its conjugate acid. So that means that if this one is going to accept, then the conjugate acid has to have one more hydrogen than this one started with. So I'm going to say that this conjugate acid H3PO4. That's its conjugate acid. So that one would donate, and if it donated, I just said that. Let me go back over and do this one. Yes, I'm sorry. Just lost my train of thought for just a second. If that donates, then you're going to lose one here. What you have remaining is going to be the base. If I start on this side, I'm going to have, this is the base, so therefore this one had to have one more hydrogen than this one. So then that would be the acid because it donates, and that would be the base because it is going to be what remains left over. All right, so we have the base, conjugate acid. Now, I always get someone who says, Mr. Vance, I kind of understand this, but I don't see the big picture. That brings us to our conclusion board. So I'm going to wrap this up. Make sure that we, first of all, understand that in a Bronsted-Lowery acid, it donates a hydrogen ion. A Bronsted-Lowery base accepts a hydrogen ion. So if I'm going to write out what is the conjugate acid base pairs, then it's talking about how it's going to dissolve in water. So this, I just use capital A, means it could be any acid. It could be a HCl, it could be HSO4, it could be any of them. So we have H, means it's the acid, so it's going to donate. We have water, which means it's going to accept. So therefore we end up on the other side having the H3O, that means it accepted, and it's left with just the A ion. So what this tells us is this has to be the acid, this has to be the base. So whatever's on the other side has to be the conjugate of that. So this is my conjugate acid. What accepted that hydrogen? That H3O. So that has to be the conjugate acid and the conjugate base. So this is going to be what's left over. So the easiest way that I do it is read it from right to left. If I have H3O over here, who donates? Well, if I go back this way, that one donates the hydrogen, that one's accepting. So you get the acid base, conjugate acid, conjugate base. All right, I hope this helped, and this should be able to, now you should be able to finish up the first two assignments, which is the first 2 pages of the notes. If you have any problems, just give me an email or a remind me, and I'll try to address them.